dealing with. And these are the things for reaction stoic, because it comes with the reaction. These are the things you have to be able to do. First of all, let's start with the molar mass. So the molar mass of the C6H5Cl, the molar mass is we're going to say 112.6, and I gave this to you in class. The molar mass of this, when you calculate it out, would be 147.4. And the molar mass of the DDT is 354.5. It's basically, those are the molar masses. Water's 18, but we don't really use water in this. Now keep in mind, it is a limiting reactant problem, and when they ask you what mass, it's the theoretical yield, so they're asking us about DDT. So we're going to go from here to here and there to there. Those are my first two grids, reactants to the products, right? Departure, arrival, both comparing DDT. So here we go. So the first one, I'm going to take the chlorobenzene, the amount given, which is 142. So I'm going to take this, I'm going to make a grid like this. I'm going to drop the 1142 grams of chlorobenzene, which is C6H5Cl. Goes right there. The molar mass is 112.6. So I put that right there, grams of C6H5Cl. Because if I have grams here, the tile that goes here is molar mass. 1 mole C6H5Cl. Now, at that point, we know that there's moles in the upper part of the grid, so it's time to use our ratio, 2 to 1. So 2 moles of C6H5Cl equals 1 mole of DDT, which is going to be C14H9Cl5. See how I'm writing all the labels? You have to do that to get full credit or even carried air on the AP exam. It's critical. So make sure you're doing all that, because some of you guys in your homework have not been, and on a test, a lot of your points come from the setups. In the AP exam, there's points for the setups, which you're going to definitely have to pay attention to. So I got 1 mole of C14H9Cl, and then that's going to be equal to 354.5 right there. So I have that one. So if I go here, that's the value of chlorobenzene. So then I'm going to run that one in a second, but I'm going to set up my other grid. So I'm going to set up my other grid. I'm going to do the same idea here. Let's get a 3-step grid, grams of grams. So I'm coming back and I've got 485 chloral. So I go 485 grams of chloral, which is C2HOCl3, I believe it is, HOCl3. Molar mass of chloral, I gave it to you, is 147. As soon as you have grams here, you know you have to put 147 grams, 0.4 of C2HOCl3. Equals 1 mole, because it's molar mass of C2HOCl3. Now I got moles in the upper part of the grid, so it's time to go 1 to 1. So 1 mole of chloral, which is C2HOCl3, is going to be equal to 1 mole of DDT, C14H9Cl5. It's supposed to be an HCl5. And then we said 1 mole of DDT, I'm just going to write it for speed's sake, is equal to 354.5 grams of C14H9Cl5. Yeah, Cl5. There we go. I forgot the label there. My bad. All right, so I'm going to run it on my calculator. DT for the first grid, which is 1798, because 4 sig figs went in, 4 come out. 3 sig figs go into the grid here. So I get 1166, but I got to round it up. So that's going to be 1170 is 3 significant figures. So clearly, we just established that this is our limiting reactant, the chloral. Our excess reactant is going to be the chlorobenzene. So this is my excess reactant. So that's the first thing. So then we know how much DDT is going to be formed. It's going to be 1170 with sig figs. Limiting reactant we know is going to be the chloral. Chlorobenzene is going to be the excess reactant. And then we ask how much of the excess is left over. That's where we're going to go in and use the grid. We're going to reuse our grid. So essentially what we're going to do is we're going to recycle, help save the planet. But what we would do is right here, we would do this. So watch, I'm going to go ahead and grab this front piece right here, the bottom too, but it won't let me snapshot it like that. So we're just going to do this. We'll go here. Oops, I just went there. Oops. So I go there, I got to put it, where is it? I'll have to find it. I'll find it and set up for the next video.